Average value of a function. So you're used to finding an average by adding up all the numbers and dividing by however many there are. Like, right, that's how you find your average test grade. Add them all up and divide by 3 or 4, and that's your average. Well, for a function, that's a little bit harder to do because you don't have, 3 or 4 points. You have like 1 million points or more than 1 million points. Let's see if I can draw a picture here. Let's draw some function from A to B, something like that. Doesn't need to look exactly like that. And let's say our goal is to find the average value of that function from A to B. Well, even if there were y values over here, I don't know how to add all of those values up because there's an infinite number of values between A and B. So I'd like to add them all up, but that doesn't really seem possible. So let's back up and do this a little bit different way. Let's say, let's kind of guess first. I don't know. I'm going to say the average value is, just kind of eyeballing it, is maybe right there. Just going to say that's my average value. If that's the average value, then that height should give me the same area that the black area is. Maybe this way is. So I want the red area to equal the black area. If the red equals the black, then I've found my average value. So the average value is f of c if the black area equals the red area. Do you buy that? Does that make sense? Yes? No? 1 yes. 18 non-responses. 2 and 17. 3 and 16. Okay, we're making progress. So I don't know what f of c is, but somehow I want those two areas to equal each other. Well, the black area, I know how to find the black area. That's what we were just doing. That's area under the curve. That's integral from a to b of f of x. I mean, that's what that symbol means. Integral from a to b is the area under the curve from a to b of f of x. The red area, that's even easier because that's a rectangle. That's just like base times height. So the base is b minus a, and the height is this f of c that we don't know what it is. But now I can solve for f of c. So the average value, the average height of that weird looking shape is 1 over b minus a times the integral from a to b f of x dx. You got to know that, average value. So I tried to derive to show where it comes from because that will help some people remember it. It's the total area divided by the width. Other people will forget about the picture and the derivation and they'll just straight remember the formula, and I guess that's okay too. But I like knowing where the formula comes from. It helps me remember the formula. Because I remember it as the area divided by the width gives me the average height. Area divided by the width, the average height is the area divided by the width. That's not the full calculus version, but that's where it comes from. So remembering that might lead you to the actual calculus formula. So if we ask for what's the average value, by the way, this was on a test, the last test, when you had to do, you didn't even know it was, but you estimated the area under the curve with a left or right Riemann sum, and then you had to multiply by 1 over 20. I don't know if you remember that test question or not. And you guys didn't really know what you were doing. You were just following what I laid out for you to do. But that 1 over 20 meant that you were finding an average value. We sort of did this already. You just didn't know that you did it already. So the second part of today, and then we'll use this stuff, is the mean value theorem for integrals. The mean value theorem for integrals. Should have done a warm-up with mean value theorem for derivatives. Note to self. Tomorrow warm-up, MVT for derivatives. Because you probably don't remember what that is. But let's keep going with this, and then we'll rewind and do derivatives tomorrow. If f is continuous on A to B, again, continuity prevents things from jumping around or getting crazy. If f is continuous on A to B, there exists a number C on A to B such that, now we're gonna rewrite the average value theorem basically, or the average value equation. F of C equals 1 over B, integral from A to B, f of x dx. So the average value basically tells you the y value, the average height. The mean value theorem says that C, the x value, is on your interval. So the average value theorem, or average value, tells you the average height. The mean value theorem tells you, well, that height occurs somewhere on the interval. And so for our picture right here, there's C, there's the place where that height occurs. It occurs between A and B. So that's why these two sort of concepts or lessons always go together, because it uses the same thing. One's talking about the y value, what's the average height. The mean value theorem is saying, well, where does it happen? Well, it happens in between A and B. Here's how these problems look. They all look pretty much the same. We'll do a couple of examples, but they're all the same type question. F of x equals x squared plus 1. Let's find the average value on 0 to 2. We could just do this formulaically and get an answer, but let's draw a picture and see if we understand even what the question's asking. Plus, that'll help us make sense of the answer. So, a little bit of a side note here. If you're comfortable without the picture, you can just kind of plow through the formula and get an answer. but I want to understand what's going on. X squared plus 1. I pick one that we know what that graph looks like, right? Just regular parabola, shifted up one. From 0 to 2. So 1, 1, and 2, 4. 1, 2, 3, 4. So we'll end up there at 5. So parabola, we're only really concerned about what's going on between 0 and 2. Anybody want to take a guess at what the average value is, looking at the picture? I mean, you're not going to guess it exactly right, most likely, because it's...
1,415.
What's that? Pi? So 3-ish?
Yeah.
I'd buy 3-ish, right? That looks right. It'd be in there somewhere. So think about 3. We'll see if Nick is right. I don't know. I don't know that it's 3. If you draw a little line there, there's a little bit of area right there, and there's a whole lot of missing area down here.
2.26.
So I think it's going to be less than 3, but who knows? It's definitely in between 1 and 5, right? Somewhere around 3, maybe a little less than 3. But doing that kind of thing helps us process what's going on. So Nick, you sticking with 3? Macy's going with 2.2 something.
Let's stick with pi. Let's stick with pi because I'm hungry.
Pi because you're hungry. All right, so the area, let's don't do the 1/2 yet. The area would be 0 to 2, x squared plus 1 dx. That'd be the total area. But I want to divide that by the width, so 1 over 2 minus 0. We're thinking b minus a. That'll be the average height. One half, and then integral. Well, this is one where I'm going to have to do the antiderivative. If I knew the area of this thing, then I wouldn't have to be doing what I'm doing. I want to know the area, so I'm going to antiderivative x cubed over 3 plus x from 0 to 2. So I'm just going to leave the 1/2 out front. If I plug in the 2, I get 8/3 plus 2 minus, well, if I plug in 0, I'm going to get 0, but just to show what's going on, I'll show the zeros in there. And I guess that would be a safe stop for the answer, but we want to know who was closest. Like, we want to know what the answer is here. So that would be a safe stop. Let's see. 8/3 plus 2 would be 8/3 plus 6/3, 14/3 times 1/2 would be 7/3, and that would be what, 2 1/3? What did Nacy say? 2.2 something?
2.26.
2.26 and 2.4. Those are about the same distance away. So we got 2 winners.
I just did it right once I'm over
2.26 just sounded like a nice number.
Yeah, it was pretty close. But we found the average height, so it wasn't 3, it was more like 2.3. And that looks a little bit better. That means the area above the line is equal to the missing area below the line there. That's my average value. Either the long statement or 7/3 or 2.3 repeating. All of those would be acceptable answers. So that's the y value that we were looking for. So that's part A. Part B is, well, where does that occur? Well, it was above 2, so I mean the x value is going to be more than 1, but I don't know how much more than 1. Oh, we're guessing again?
1.3.
1.3. Okay.
Alright.
Find value of C guaranteed by the mean value theorem. So fancy talk, it just means, well, where does that happen? You found the average height. What's the x value that goes with that average height? So that means, okay, f of c, we know the average height is, let's go with 7/3 rather than 2.3 repeating or that full expression. If we plug in c for f of x, we get c squared plus 1 equals 7/3. All right, I want to know what value of c gives me 7/3 for an answer. So MVT sounds fancy, but it's like just algebra stuff. Like figure out what the x is to get 7/3 for an answer. So c squared equals 4/3. So I square root both sides. Don't forget when you square root both sides to put the plus or minus on there. Although something is not quite right with that answer, and you might remember this from MVT the first time around. One of those, there's two answers there, but one of those is not right.
It can't be negative.
Why can't it be negative?
Because the graph is positive.
It's got to be between 0 and 2. So I think you can kind of see what happens if you extended this back the other way. It happens on the other side, but we're not looking on the other side. We're only allowed to look from 0 to 2. So on 0 to 2, only the positive one. So that's our x value. So average value gives you the height. MVT can tell you where it happens. And now I just want to see how close your guess was. 2 divided by square root of 3. 1.15. What was the guess? 1.2? 1.3. That's pretty close. So, two things today. Find the y value, that means the average height, and then find the x value that goes with it. Let's do one more. Because we never want to go too long, too many days without some trig. The collective groans. Love it. If f of x equals sine of x on 0 to pi, it's going to be the same two questions. Find the average value, that's the average height, and then part B will be, where does that happen? And obviously it's got to be between 0 and pi. Alright, average value. I don't really memorize the formula. I have the words memorized more than the formula memorized. It's the area divided by the width. The total area divided by the width of the interval. So the width would be 1 over pi minus 0. The area is the integral from 0 to pi sine of x dx. I don't know if we need to draw a picture of this one or not. We don't need to play the guessing game, but there's sine of x from 0 to pi. So it reaches a max of 1. And by the way it's curved up, I'm going to guess the average value is above a half. That's my guess. Not very. So if you need to write down a guess for yourself, go for it. I can look and make my guess, but above a half. That's all I'm going to guess. Less than 1 though, for sure.
2/3 on the dot.
2/3 on the dot. I don't know. There's pies in here, so I'm kind of doubting 2/3 on the dot is going to be it.
There are your pies.
Here's your pie guess.
2 pi over 3.
All right, so the integral of the antiderivative of sine Who has an antiderivative of sine?
Negative cosine. I'm gonna go on a limb, negative cosine. Oh, it looks like it's cosine.
Is it? Well, wait a minute. I was intentionally leaving that blank. Is it positive cosine or negative cosine?
No, I got it right. It's negative.
It's negative cosine. From 0 to pi. You can distribute the 1 over pi as you go, or you can just leave it out front and worry about it later. I'm going to do that. So it's evaluate at the top one, minus evaluate at the bottom one. Might have been good to pull the negative out front as well, but well. So negative cosine pi minus negative cosine of 0. Yeah, now I'm wishing I'd pulled the negative out front to start with. Oh well. So 1 over pi negative cosine of pi is negative 1. So negative 1 plus cosine of 0 is 1. So my average height, my average value is 2 over pi. If you had a guess, I don't know what 2 over pi is. 0.64. What did you say? 0.63? Very nice. 2/3 is pretty close as well. 0.66, 0.63. Okay, mean value theorem says, well, that happens somewhere, and you may remember this from the first mean value theorem. It's guaranteed to happen at least once. I'm already thinking this is happening twice. So part A is find the average value. Part B is, well, where does it happen? Find C such that f of C equals the average value. Find the x value where it happens. So sine of C equals 2 over pi. That's not a unit circle value, right? You don't remember that showing up on the unit circle. So how do I find, how do I figure out what C is? You can't divide by sine.
Multiply by.
It's something that has to do with pi over 2. You got to work this probably.
It does have to do with, how do I undo a sine?
Negative cosine.
Oh, is it like the 1 minus thingy or no? Like the 1 minus. No?
No, but you're close. Look at your calculator. Maybe that would help you remember. There's sine. How do I undo sine?
Second sine.
Second sine. Inverse sine of 2 over pi.
What's the derivative of sine? Second sine.
No, not. So I'm in radians. Inverse sine 2 over pi. 0.69. 0.690 if we want to give 2 or 3 decimals. Okay, that's not wrong. But looking at my picture, that's this one. But there's another one. It's not double it. You did this in pre-cal, but this has been a long time ago. Your calculator tells you an answer. How do you get the other answer from your calculator? It's not 1 minus, it's pi minus. And you can kind of see that from the picture. This distance is C1, which means this distance is C1. So if we do pi minus our first answer, pi minus our first answer, pi minus answer, 2.451. And then we could look at our picture and make sure that makes sense. Again, you can do all this without the picture, but I think drawing the picture helps make sense of it. Yeah, 2.45 is less than pi. So there's two places would that give us the average value of 2 over pi. All right, your assignment, yes?
Would inverse sine of 2 is pi and then pi minus inverse, would that be a safe stop, or would you have to?
Yeah, actually, safe stop, because this is calculator ready, those would be a safe stop. That's a good question. That would be a safe stop. All right, the assignment is the worksheet on average value. Answers are posted in Schoology, and you can kind of see what the directions are. On problems 1 through 4, part A, find the average value. So that's the average height. Part B, find C such that the average value equals f of c. So that means like find the x value. Part A is find the y value, the average height. Part C is basically sketch a graph that kind of helps you make sense of the picture. And you could definitely do that with calculator. All right, the others are a little more complicated, but it's still the same thing. Find the average value and then find the x value.
Guessing you want it on a separate sheet?
I'm going to say I think so, because 1, 2, 3, 4 are awful tight, and it takes some work to find those. The good news is, or I guess it's good news, tomorrow's a block day, so we'll have time to go over some of these before we start the new stuff for tomorrow. So, yes, this is kind of compressed in one day, but we'll have a good amount of time tomorrow to answer some of these questions. So give them a try. Again, answers are posted in Schoology, and not just answers, but solutions with work shown. And again, we'll go over them tomorrow.